A traveler from beyond our solar system is quietly passing through our cosmic backyard right now. Its name is 3I Atlas, officially the third interstellar visitor ever recorded by humans. It isn't bound to the Sunday. Its orbit is hyperbolic, meaning it will sweep in once, reveal a treasure trove of data, and then vanish back into interstellar space forever. And right up front, let's be clear. It poses no danger to Earth. Its closest approach will still be hundreds of millions of miles away. This is a story of science and discovery, not a story of threat. Picture a dark, ancient block of ice and rock drifting in interstellar darkness for longer than human history. Now it's come close enough to feel the warmth of the Sunday. Its surface begins to crack. Gases and dust escape, tiny jets firing like millions of microscopic rocket thrusters. Around the nucleus, a fuzzy cloud, the coma, swells, and stretching away from the sun, a long glowing tail forms. With 3I Atlas, this process is happening right before our eyes. Day by day, its activity is rising, its brightness is climbing, and its story is getting more intriguing. The freshest updates center on three themes: the timeline of key observations, the comet's visible activity, its growing coma, tail, and greenish glow, and the ongoing debate over its size and mass. For the first time, we have a rare three-point observation plan: a Mars-based viewing window in early October, Perihelion in late October, and a follow-up campaign from the direction of Jupiter in early November. 3 vantage points, 3 pieces of a puzzle. Together, they may reveal things the 2 earlier interstellar visitors, Oumuamua and Borisov, never showed us. Let's start with the timeline. In early October, 3I Atlas passes through space not far from Mars's orbit. In planetary terms, not far still means tens of millions of miles, but that's close enough for orbiters around Mars to try a unique observation angle. From Earth, the comet is hidden in solar glare, but from Mars, the geometry works. Think of it as having a second camera in the perfect spot to capture the moment before the main event. Scientists want to know, how quickly is 3I Atlas waking up? How fast is the coma expanding? Are there strong localized jets carving out features? By late October comes Perihelion, the closest pass to the Sunday. That's about 1.4 astronomical units, or roughly 130 million miles. Safe, but close enough for intense solar heating. This is the moment when cracks deepen, fresh ice vents, and the comet might flare into maximum brightness. Researchers will be watching closely for just how dramatic this outburst is. Then, in early to late November, comes the Jupiter system window. By then, the comet may still be highly active. The tail and coma could be at their most extended. From a distance, it could look like a ribbon of light stretched across the void. For scientists, it's prime time to measure spectra, identify which gases dominate, and determine how dust grains reflect and scatter sunlight. With perspectives from Mars, perihelion itself, and then Jupiter's neighborhood, we can build a 3-dimensional, time-lapse portrait of an interstellar comet's behavior. From Earth's ground-based telescopes, we'll have to wait until early December. Until then, 3I Atlas is too close to the sun's glare. But that gap actually works in our favor. We'll return to observing it at just the right moment to compare before, during, and after perihelion. 3 acts of one rare cosmic play. Now, about the greenish glow that has everyone talking. Photos in September showed 3I Atlas changing from a faint reddish fuzz into a comet with a distinct green tint. Green in comets usually means the presence of dicarbon C2 molecules that fluoresce under sunlight. Sometimes cyanide contributes to the effect too. The twist here is that early spectral data suggests the usual carbon molecules may not be as abundant as expected, hinting that something unusual is happening. Perhaps fresh ices have just been exposed. Perhaps other molecules are involved. In October and November, better spectra should tell us which emission bands dominate. If it's C2, the classic story holds. If it's cyanide, the chemistry points to something different. Either way, the answer tells us about the environment where this comet first formed, likely far from its original star, in zones cold enough for fragile ices to condense and persist. And about that tail. Sometimes you'll see images where the tail looks faint or absent. That doesn't mean the comet isn't active. Comets often grow both a dust tail and an ion tail. Dust tails are thick, slightly curved, made of solid particles. Ion tails are thin, straight, and highly responsive to the solar wind. Different telescopes, exposures, and filters highlight different tails. As 3I Atlas ramps up, both types may appear, weaving into each other, producing those gorgeous double-tailed images we've seen with other comets. For scientists, the length, curve, and orientation of these tails are like measuring instruments, revealing outflow speeds, particle sizes, and solar wind conditions. One of the more debated topics right now is size and mass. The nucleus is hidden inside that glowing coma, so we can't measure it directly. Instead, astronomers watch the orbit with extreme precision. If jets are pushing it off track even slightly, that shows up as a non-gravitational acceleration. But so far, months of observations haven't revealed strong deviations. That suggests the nucleus might be large and heavy enough that the jet thrust barely matters. Some analyses have floated estimates of tens of billions of tons, an enormous number, but this is inference, not direct measurement. It depends heavily on assumptions about venting rates, dust grain sizes, and jet direction. The real test comes at perihelion. If after peak activity the orbit still looks unchanged, the massive nucleus hypothesis gains weight. If subtle accelerations do show up, those estimates will be revised downward. That's how science works, bold ideas tested against new data. Safety is worth repeating clearly. At its closest to the Sun in late October, 3I Atlas will still be 1.4 astronomical units away. Its closest approach to Earth, in December, will be even farther, around 1.8 astronomical units. That's farther than the Earth is from the Sunday. The long tail you see in photos may stretch millions of miles, but remember, it's made of microscopic dust and thin gases, more like a glowing fog than a solid spear. Beautiful, but not dangerous. Another fascinating angle is space weather. If the Sun fires off a coronal mass ejection, a storm of charged particles right as 3I Atlas is active, the comet's tail could ripple, kink, or even break and reform. To the eye, it would be stunning. To researchers, it would be a laboratory experiment, showing how solar wind and magnetic fields interact with foreign material. And because this comet is moving faster and from a different direction than most, it gives us a chance to test models under unusual conditions. So what will we ultimately learn? First, a clearer chemical fingerprint of an interstellar comet. Oumuamua gave us almost no dust and left us puzzled. Borisov behaved more like a traditional comet. 3I Atlas seems to be both familiar and different, active, dusty, but chemically surprising. Second, the mass question should become clearer. Third, the movie of before, during, and after perihelion will anchor our models of how ices sublimate and tails evolve. Each piece adds to our understanding of how comets behave, not just here, but across the galaxy. Zooming out, there's even a bigger idea. Some planetary formation models suggest that interstellar objects like 3I Atlas can get captured by young star systems, seeding their protoplanetary disks. By serving as ready-made building blocks, they might help planets grow faster than they otherwise could. We don't have direct proof yet, but each new interstellar visitor helps move the theory closer to testable science. Let's wrap the timeline into a few easy-to-remember dates. Early October, Mars-based orbiters get a side view. Late October, perihelion, the big solar heating event. Early to late November, the Jupiter window, the aftermath. Early December, the comet reappears for Earth-based telescopes. Along the way, watch for 4 signs: the intensity of the green glow, the structure of the dust and ion tails, hints about the nucleus mass, and how space weather shapes the scene. At the end of the day, 3I Atlas carries grains of ice and dust, born in a place we'll never visit, far beyond our Sunday. It's wandered the darkness for eons before brushing past us now. It will leave again, never to return. But its fingerprints will remain in images, in spectra, in orbital data, and in scientific papers written years from now. For us, it's a rare gift, a fleeting chance to witness an interstellar traveler up close, and to learn a little more about where planets come from, how systems evolve, and where we ourselves fit in this vast universe.